And I am Dr. Radha Subramaniam. So today we are going to learn a trick to find Vanthoff factor. You might all be familiar with Vanthoff factor, which is from the lesson Solutions in Class 12 Ncert Chemistry. Okay, so before moving on with the trick, first of all I will tell you what is meant by colligative properties. You should have heard about colligative properties. So these are a special type of properties, so which mainly depends upon only the amount of the substance and not on the nature of the substance. You know what is meant by nature of the substance, okay? The behavior of the substance, and it's entirely independent on the nature of the substance and depends only on the amount of the substance, okay? Now suppose we'll consider one scenario here, that is X particles of Na plus, that is sodium ion, and X particles of Mg2 plus, that is magnesium ion. So see, in both cases the number of particles are amount is same, that is X. Okay, since they are same, both are X particles, that is Na plus is also X particle and Mg2 plus is also X particle. So that means what you understand from this, that these two have the same properties, okay? And suppose what happens if the number of particles changes, then the colligative property also will change. Okay, so what do you understand from this? The colligative properties depends on only on the amount of the substance. Okay, now we will consider one equation here, that is AB, a substance AB dissociates. What is meant by dissociation? Breaking up into A plus and B minus. Okay, and what happens if A plus and B minus combines? It becomes AB, that is what we call as associating. So dissociation means break up and association means getting combined. Fine, okay. Now what happens after association? Number of particles will decrease. So because of that the colligative property also will change. Now considering the colligative properties and association, dissociation, all these factors, a scientist called, a chemist called Vanthoff, he came with a factor I, okay, small I, okay, which is used to calculate the colligative properties. So there should be some method or way in which you can calculate the colligative properties. So that is why Vanthoff found out a factor called I, which is very simple equation. See, I is equal to total number of particles after association or dissociation divided by total particles before association or dissociation. Just remember this simple formula. Now let us take this case here. So the first case, what is I? Before number of particles after association or dissociation. Here after dissociation 2 particles are there and before only 1 particle. So 2 by 1, I is equal to 1. Clear? Okay, I think you all understood till here. Now we will take the case of dissociation. Suppose 1 mole of A gives n mole of B. Okay, that is 1 mole of A gives rise to n mole of B. Now there is something you should know about a degree of dissociation, which is called alpha. Degree of dissociation is indicated by the letter alpha. So what happens at equilibrium? After dissociation, some moles of A from here gets converted to B. After dissociation, some moles, beginning there was 1 mole, and after dissociation we can take it as 1 minus alpha mole will give you n alpha moles of B. Okay, so what is the total number of moles after dissociation? 1 minus alpha plus n alpha at equilibrium. Okay, so the total number of moles you can calculate 1 minus alpha plus n alpha. Now we will rearrange the equation and write it as 1 plus n alpha minus alpha. Now we will combine these two terms together. So we will get 1 plus, take out alpha which is common factor, n minus 1. Fine. So what do we get here? Equation I is equal to, what is I? I is the Vanthoff factor, that is 1 plus n minus alpha divided by 1. that is total number of moles divided by number of total particles before association or dissociation. Okay. Now I is equal to 1 plus n minus 1 into alpha, remember that. Okay. And now we will take two cases and see how can you apply the trick, how do you apply the trick. So first we will take the case of dissociation. So for 100% ionization for a strong electrolyte, so 100% means 100 by 100, which is equal to 1. So in that case alpha will be equal to, degree of dissociation will be equal to 1. So what happens is that I is equal to 1 plus n minus 1 into alpha, alpha is 1. If you substitute 1 here, this 1 over here, 1 and 1 will get cancelled and you will get I is equal to n. Put it in a box, that is an important thing to remember. So suppose for strong acid C, HCl dissociates into H plus and Cl minus, so then I is equal to 2, no, get 2 particles here, that is number of moles is 2, so I is equal to n. So if I is equal to 2, n is equal to 2, I is also equal to 2. For H2SO4 it dissociates into 2H plus and SO4 2 minus. So 2 plus 1, 3 moles are there, I is equal to 3 because I is equal to n. Now for the case of strong bases NaOH dissociates into Na plus and OH minus, I and n all will be equal to 2. For K2SO4 2, K plus and SO4 2 minus, 2 plus 1, 3 moles are there. CH3COOH, CH3COO minus and H plus 2 moles are there, so n is equal to 2. Now we will take one case over here. See, suppose CH3COOH is 10% ionized, you have to find out I, they are asking you to find I is equal to how much. So what is alpha? That is 10%, which is equal to 10 by 100. What is 10 by 100? It is 0.1. Now let us take the formula. I is equal to, what is I? We wrote it here already, 1 plus n minus 1 into alpha. So we will substitute 1 plus n minus 1 into alpha. What is alpha? 0.1. So 1 plus n minus 1 into 0.1, that is 1 plus 0.1. Okay. Because how do you see here we calculated n as 2. Fine. When acetic acid dissociates, you will get 2 moles. So n is equal to 2. So 1 plus 2 minus 1, 1. 1 into 0.1 is 0.1, you get 1.1. So that is the solution for this. Easy, isn't it? Once you get this, then the remaining is easy. If you know the Vanthoff factor and the degree of dissociation relation, you can easily work this out. Now for case 2, this is for dissociation, and for association. See, n moles of A gives rise to 1 mole. Okay. So what happens at equilibrium? Some moles of A will be converted to An. Okay, here. So what happens is that at equilibrium, here 1 minus alpha. Now what happens here? See, from n mole we get 1 mole. So from 1 mole how much do you get? Just cross multiply. So 1 into 1 divided by n, which is equal to 1 by n. Okay, now just you can total find out the total moles at equilibrium. See here 1 minus alpha is equal to, already you got 1 by n. Okay, 1 by n into alpha. So here just total number of moles will be equal to 1 minus alpha plus 1 by n. Just rewrite the terms, and then what do you get here? See, 1 minus alpha plus 1 by n alpha, we are combining together these two alpha terms. Okay, so 1 plus alpha, 1 into alpha is alpha, isn't it? Alpha divided by n minus alpha. So these two when you combine together, you get 1 plus 1 by n minus 1 into alpha. That is equal to I. So this is how you calculate the Vanthoff factor for association. That is, n moles of A gives 1 mole here. So from n mole we get 1 mole. So for 1 mole we can calculate by cross multiplying 1 by n. Okay, so total moles you can calculate at equilibrium. Just 1 minus alpha is equal to 1 by n into alpha. Then from that you just do the substitution and find out the value for I. So this is a easy method. See, whenever you get sums like this, just remember the formula. I think that is for association. I is equal to, this is the formula, and you apply this, and then the formula for I in the case of dissociation is just you remember these two formulas, you can easily solve the any sums which come from this Vanthoff factor. Hope this concept is clear for you, and I hope you are all preparing well for your upcoming exam, and we have got only just couple of days away, and all of you just practice everything well, and wish you all the best, and do like, share and subscribe to our channel Chemistry Made Simple for Neet, and thanks for watching the video.